Hi guys, welcome back to our channel again. This is ChemXplain. As much as you remember, in previous session, we discussed over molar analytical and molar equilibrium concentrations. We also did some calculations on some problems, so you somehow got familiar with the process. Now, in this session, we are going to continue the topic of concentration. So we are going to cover percent concentration, PPM and PPB. As the subject of concentration ends and finishes, we can go to next topic. Okay, before we start, if this is your first time in ChemXplain Analytical Chemistry series, I highly recommend to start from the first episode. You can access the first episode so easily by clicking on the top right button here. Okay, let's start. When it comes to percent concentration, it actually provides three different definitions. The first one is called weight percent, which you can show with W divided by W also. It means the weight of the solute divided by the weight of the solution times 100%. The next one is going to be volume percent, which can be illustrated using V divided by V, and it means the volume of solute divided by the volume of solution times 100%. And the last definition would be weight volume percent, which can also be shown using W divided by V. It means the weight of the solute divided by the volume of the solution times 100%. We are going to cover some problems in the following examples. But before the examples, let's go to the definition of PPM and PPB. As it is shown here, the definitions of PPM and PPB are highly similar. But what does PPM and PPB actually mean or stand for? For PPM, we can say parts per million, while for PPB, we can say parts per billion. As you take a closer look to the definition for PPM, we have mass of the solute divided by the mass of the solution times 10 to the power of 6, which means million. As for PPB, we have the mass of the solute divided by the mass of the solution times 10 to the power of 9, which means billion. That's fine. Now, let's waste no more time and head to the examples section. Okay, it says, what is the molar concentration of potassium ion in a solution that contains 63.3 ppm of K3FeCN6? As it is shown here, the molar mass of this compound is also given. Okay, as we discussed earlier, the definition of ppm is 1 part of the solute divided by 1 million parts of the solution. Knowing this definition, we can say that 63.3 ppm also means 63.3 milligrams of solute divided by 1 liter of the solution. 1 liter of the solution is also equal to 1 kilogram of the solution here, because our solution is really dilute. Okay, now from here we can say that in each liter of our solution, we have 63.3 milligrams of K3FeCN6. 6. Now, we have the grams. We want to convert it to moles. How is that exactly possible? Really simple. 63.3 milligrams divided by 329.3 grams per mole. The answer would be 1.922 times 10 to the power of minus 4 moles per liter. Okay, as we take a closer look, we can say that this concentration is for K3FeCN6. But the question says we need to find the concentration of the potassium ion. Okay, so really simply we can say in each mole of K3FeCN6, we have 3 moles of potassium ion. So to calculate the concentration of potassium ion, we can simply multiply our answer by 3. So 1.922 times 10 to the power of minus 4 times 3. This is going to give us the answer. 5.77 times 10 to the power of minus 4 molars or mole per liter. That's fine. Let's go to next example. Because it's sometimes really hard to use large scientific numbers of concentrations in our calculations, we try to use something else instead. Okay, here we use the p function or the p-value, which means p of x equals minus logarithm of the equilibrium concentration of species X. It can help us to make our calculations much easier. In the following example, we are going to discuss it completely. Okay, it says calculate the p-value for each ion in a solution that is 2 times 10 to the power of minus 3 molars in NaCl and 5.4 times 10 to the power of minus 4 molars in HCl. To start solving this problem, I highly recommend that you start from the concentration of hydronium ion and sodium ion. You may ask why. Let me explain. Look at the hydronium ion. It only appears in one of our substances. So the concentration of hydronium ion is here, 5.4 times 10 to the power of minus 4 molars. You can see the same for sodium ion as well. It only appears in one of our substances. The hard part of this problem is the concentration of Cl ion. So let's start. The first part we can say pH equals minus logarithm. Okay, let's practice one more example and wrap this session up. It says, calculate the molar concentration of silver ion in a solution that has a pAg of 6.372. That would be really easy, as the formula says pAg equals minus logarithm of the concentration of silver ion, which is 603.72. Okay, now we can say logarithm of silver ion's concentration is minus 6.372. From here, the concentration of silver ion can easily be calculated, which is 4.246 times 10 to the power of minus 7, or we can say 4.25 times 10 to the power of minus 7. Okay, that was it for today. Hope you enjoyed the video. If you want, I would be really thankful to hit that thumbs up button, like the video, and subscribe. For more chemistry content, follow us on YouTube, Instagram, and Telegram. This is ChemXplain.